Let's find the absolute maximum and minimum of this function right here on the interval 0 to 4. Now, anytime we're looking to find an absolute maximum and minimum value of a function on a given interval, we need to find the critical points first, and then we retain any of those critical points that happen to fall in the given interval, and then we're going to plug those critical points and the endpoints into the original function. The largest y value that we find, that's going to represent our absolute maximum. The smallest value we find is going to represent the absolute minimum. To find the critical points of a function, we need to take the first derivative and set that equal to 0. And we need to look at where that first derivative might be undefined. In this case, our derivative is always defined. So we set it equal to 0. And we solve for x to get x equals 3/2. That's our critical point. And we'll notice that that critical point does fall in the interval 0 to 4. So we're going to take the critical point and the two endpoints and plug those into the original function. And let's see what we get. If we plug in x equals 0 into the original function, we just get 3. Plugging in 3/2 involves a little bit of work with fractions. I'm going to try to use all this space, so I'm going to work horizontally here. I'm just going to find a common denominator, which in this case is going to be 4. And hopefully I didn't make any mistakes there. I'm getting a y value of 3/4 for our critical point. And when I plug in x equals 4, I'm getting a y value of 7. So you'll notice that of these three y values that we found here, the smallest is 3/4 and the largest is 7. This is going to represent our absolute minimum, and 7 is going to represent our absolute maximum. So we can make a quick statement down here. The absolute minimum value is 3/4. And that value of 3/4 happens when x equals 3/2. And the absolute maximum value of the function on this interval that was given is 7, we found, and that happens at the endpoint when x equals 4.